This is 5, 6 inequalities in two triangles. So we have a hinge theorem, and it tells us that if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the longer third side is across from the larger angle. So first, you need to make sure that two sides are congruent. Hang on. There we go. All right, so the first conditions is if two sides of one triangle are congruent to two sides of another. So you just make sure of that. So AB is marked as congruent to DE, and AC is marked as congruent to DF. So yes, two sides are marked congruent, and the third side is not marked congruent. So that tells us we can compare the sides. So this, and if this is different, then it's across from this. So if angle A is greater than angle D, then side BC is going to be greater than side EF. So this goes back to this triangle inequality theorem from Friday. The larger side is across from the larger angle, the smaller side is across from the smaller angle. And so when you have two triangles, if two of the sides match two of the sides of the other triangle, you can compare the third side and third angle. And then, of course, every time we have a theorem, we do it in the converse also, which is backwards. And now we're going to talk about the angles. So if two sides of one triangle are congruent to two sides of another, then the third sides are not congruent. The larger angle is across from the longer side. So we're just saying the same thing again. So BC is across from angle A. EF is across from angle D. So if segment BC is greater than segment EF, then angle A must be greater than angle D. So which one you're using just depends on what information is given and what you're trying to figure out. Okay, so one way of doing this is to compare the angles. Compare the measure of angle BAC and the measure of angle DAC. So when you have three letters talking about an angle, if you trace them, so B to A to C is talking about angle, this side of angle A. And DAC is D to A to C is talking about the other side of angle A. Because we can't just say angle A because we don't know which one, or would angle A be talking about the large angle A? There's three ways we could look at angle A. Alright, so we want to compare the green one to the yellow one. Which one is bigger? Well, we don't know because there's no information given about angles in that picture. But if we check to see if two of the sides are the same, so side AB is marked with a 4, side AD is marked with a 4, so they're congruent. They share a side, so that's the same as itself. So there is only a third side that we're looking at. So if we look at the 7 and the 6, the 7 is the larger side, and the larger side is going to be across from the larger angle. So that means that angle A must be greater, oh, I can't call it A, angle BAC Angle BAC must be greater than angle DAC. Because the 7 is greater than the 6. Okay, so then the other kind of problem you could have is find a range of values. So when you find a range of values, you have to solve it 3 ways. When you're asked to find the range of values, that means that you have to solve this 3 ways. All right, our x is on the side, so that's what we don't know is the side length. But we do know angles, and we need to check to make sure they're marked congruent. This side is the same as this side. They share a side, so yes, 2 of the sides of the triangles are the same. They only have a third side that's different. We look at the angle, 64 degrees, 35 degrees. So clearly 64 degrees is larger than 35 degrees. So that means that x plus 7 should be greater than 2x minus 5. So the first way is just solving the inequality for the way that we're saying that it is. So we have x plus 7 and 2x minus 5. We need to solve for x, so we subtract x, just like as if it was an equation. So we have 7 is greater than x minus 5. Add 5. And we get that 12 is greater than x. That might be the answer. So there is it's a possibility. But we also have to make sure that the sides are greater than 0, right? Because we can't have a side length 0 or less than 0, because then it would not exist. So the other thing we have to do is make sure the sides even exist. So we have to take each one of them. So I'm going to take the x plus 7 and say it's greater than 0. Because if it's not greater than 0, then there's nothing there. So that's pretty easy to solve, right? It's just subtract the 7. So x is greater than negative 7. There's another possible answer. And then the last way we need to solve this is looking at the other side, because that also has to be greater than 0. 2x minus 5 greater than 0. So we add 5. We have to make sure this side exists. 2x is greater than 5. If I divide by 2, then x is greater than 5 halves. 5 over 2, or 2.5. So x is greater than 2.5. I know y'all don't like fractions. We'll work with a decimal. All right, so I have 3 possible answers now. So to see what my actual answer is, I could sketch a number line. There's a quick sketch. I don't have to do all of the numbers. So you have negative 7, so that's the smallest one. And, hold on, is that in green? So negative 7, 2.5 is on there. And put 12 on there. And then I'm going to take a highlighter and I'm going to shade, because inequalities is not just that value, right? It's a whole range. It's one way or the other, greater or less than. If x is greater than -7, then I go from -7 to the right. And now look at the next one, x is greater than 2.5. So here's 2.5. If x is greater than 2.5, it's to the right. Can x be -7 if it has to be greater than 2.5? No, it can't. So that actually gets rid of the -7. It can't be that, because it has to be bigger than 2.5. And then I'm going to check the last one. 12 is greater than x. So sometimes it helps to flip them all facing the same direction, so I'm going to do that real quick. So 12 is greater than x is the same as x is less than 12. So all of the x's are on the left, the numbers on the right. So if x is less than 12, if I go to the 12 and I go to the left of that, because that's where the values that are less than 12 are, now I can see where my answer is. My answer is the overlapping between 2.5 and 12. So to write that, I would say 2.5 less than x less than 12. It won't always be in that form of a number less than x less than a number. Maybe it'll just be, like if I didn't have the 12, maybe it would have just been 2.5, x is bigger than 2.5. So sometimes it's just a single inequality, sometimes it's a double inequality. It just depends on the problem. So you have to solve them 3 ways. You set the inequalities where the one's greater than the other, and then you also have to make sure that they exist because they can't be 0 or less than 0. Whether it's an angle or a side, it has to be bigger than 0. And that might seem kind of confusing at first. All right, I'm going to do some more examples. Number 3, again, is just to compare. When you compare, that's one of the easier ones. We're comparing the sides. The measure of angle ACB. So here's A, C to B. So I'm talking about that angle. Or EDG. E to D to G. This angle. So that's the 2 angles I'm comparing. So to compare the angles, since there's no information given on angles, I'm going to look across. Well, actually, I need to make sure that 2 sides are the same. So I have a side measured 5, I have a side measured 5. I have a side measure 4, I have a side measure 4. Good. 2 sides are the same. I only have a third side that's different. So now I'm going to compare those. This one is 3. This one is 3.2. 3.2 is greater than 3. So that means the angle across from 3.2, angle C, has to be greater than angle D, whatever's across from 3. Or if I use the 3-letter naming system, then I know angle ACB is greater than angle EDG. So the comparing, just make sure 2 of the sides are the same. The larger angle is across from the larger side is across from the larger angle. That one's not that bad. It's the other one. When you find a range of values, when you're using 2 triangles, you have to solve it 3 ways. Okay, so the first thing I'm going to do is make sure the triangles have 2 sides that are the same. So this one has 1 line, this one has 1 line. This one has 2 lines, This one has 2 lines. All right, and there's nothing about the third side. So I can use my triangle inequalities in 2 triangles theorem. And the x is on a side. I know the information about the angle. So I compare the angles. 57 degrees, 41 degrees. So 57 degrees is my larger angle. So it's going to be across from my larger side, and that has a side of 12. So because 57 degrees is greater than 41 degrees, I know that 12 has to be greater than 3x minus 6. So that's the first inequality, is comparing them. And then to solve it, I'm going to add 6. Solve it just like you would solve an equation. 12 plus 6 is 18. 18 is greater than 3x. If I divide by 3 to get x by itself, 18 over 3 is 6. So 6 is greater than x. It's probably a good idea to write it always with the x on the left, just so when you compare them, your brain isn't working with flipping the symbols. So x is less than 6. There's my first possible answer. It may be the only answer, I don't know yet. But x is less than 6. And if you want to go ahead and start a number line, you can. Just don't really know, so I'm going to put a 6 right here. I don't know what my other values are going to be. And if x is less than 6, it's going to go this way. Okay, so my next step is to make sure that the other, I know 12, I don't have to solve anything. 12 exists. 12 is greater than 0. I don't need to solve for that. There's no variable. I only need to solve 3x minus 6 to make sure it's greater than 0. So 3x minus 6 needs to be greater than 0 or else it doesn't exist. So I'm going to need to add 6. So 3x is greater than 6. If I divide by 3, then I find out that x is greater than 2. So there's my second value. So if I go to my number line and I put the 2 on there, it'll be on this side of 6. There's a 2. X is greater, so it's going to go to the right. So I can see my range of values that are my answer is anything between 2 and 6. That's where x is. So I can write it as 2 less than x less than 6. And since now I have 3 things boxed, you need to either, I guess it might be a good idea to do circles and then draw a line through it once it's not your final answer. And then the same with the green one. Just to not be confused about which one is the answer. So 2 is less than x less than 6.